Hi students, once again welcome to our channel Manohar Motivational Thoughts. Today in this video for 10th class students you are going to learn about chemical equations lesson. In this chemical equations topic you are going to learn about what is meant by chemical equation, what is endothermic and exothermic reactions, what is a precipitation reaction, and how to balance the chemical equations. So children, what is chemical equation? Before going to chemical equation, you know in the previous classes what is a chemical reaction. When two substances react together to form a new substance, then that is called as a chemical reaction. Previously you have already learned there are some physical changes and chemical changes. Any change takes place permanently by the formation of a new substance, then that is a chemical change. Any change takes place temporarily without formation of a new substance, then that change is called as a physical change. For example, when carbon burn with oxygen, in the presence of oxygen, carbon combined with oxygen to form carbon dioxide. Burning of magnesium oxide. So these are the chemical reactions. Not only that, ripening of fruits, rusting of iron, digestion of food, these are all some of the examples for the chemical reactions. Physical changes are water changes into ice, ice changes into water, water to water vapor. So these are all the temporary changes. Water exists in three states, you know, solids, liquids, gases. So the changing of the solid ice into liquid water and liquid water into water vapor of gaseous form, these are all the temporary changes. Those are physical changes. So in this lesson you are going to learn about chemical equation. What is a chemical equation? Chemical equation is nothing but it is a shorthand representation of a chemical reaction by using the symbols and formulae. For example, when magnesium react with oxygen, it form magnesium oxide. So by using the symbols magnesium Mg and oxygen O2, it produces as a magnesium oxide MgO. So in order to balance the equation, we will write as 2Mg plus O2 2MgO. So this is a chemical equation. So formation of magnesium oxide from magnesium and oxygen, we are expressed in terms of symbols formulae. So the shorthand representation of a chemical reaction by using the symbols and formulae is known as a chemical equation. So chemical equation consists of two parts. One is reactants and other is the products. So this is the reactant, these are the reactants and these are the products. The substances which undergo in chemical reaction are known as reactants. The substances formed newly or produced newly after the reaction are called as products. So a chemical equation is having two parts. So reactants and products. So arrow mark will be separate the reactants and products. Always the arrow mark headed towards the product side. So this is about the chemical equation. Brief introduction about the lesson. Now we will discuss about the activities related to exothermic reaction, endothermic reaction, precipitation reaction, and one more extra topic is balancing equations also. So now let us see. First activity to show that there is a change in temperature in some chemical reactions. So for this activity we have to take 1 gram of calcium oxide in a glass beaker, CaO, quicklime. So this is also called as a quicklime and calcium oxide, and take 10 ml of water, H2O, water. So calcium oxide reacts with water, it produces calcium hydroxide. Suppose if you are taken a glass beaker, 1 gram of calcium oxide and pour the water, so 10 ml of water. So if you touch the glass beaker with your fingers, you feel hot. The reason is in some chemical reactions heat energy also liberated plus heat. So here calcium oxide react with water, it produces calcium hydroxide, and heat also will be liberated. So the chemical reactions in which heat energy liberated are known as exothermic reactions. So this is one of the exothermic reaction. Exothermic reaction. And sometimes they may ask what is the nature of calcium hydroxide. So when you test the calcium hydroxide with the red litmus paper, the red litmus paper will turn to the blue color. So red litmus will turn to blue. We know already the substances which change the liquids which change the red litmus to the blue are known as bases. So calcium hydroxide is basic in nature. So this is one of the important activity. Calcium oxide when react with water, it produces calcium hydroxide along with the heat energy. So the chemical reactions in which heat energy liberated are called as exothermic reaction. If you test the calcium hydroxide with the red litmus paper, it turns to the blue, so it is basic in nature. Now we will go to the second activity, precipitation reactions. So how the precipitates are formed in chemical reactions? First you have to take one 100 ml glass beaker and take 100 ml of water, take some sodium sulfate. Sodium sulfate Na2SO4 is the chemical formula of sodium sulfate, and take another glass beaker and again 100 ml of water, take some barium chloride. BaCl2 is the formula of barium chloride. So prepare the solutions of sodium sulfate and barium chloride and add these two solutions in another glass beaker. Then you will get that one insoluble undissolved substance is produced, that is called as a barium sulfate, BaSO4, barium sulfate along with the salt 2NaCl. So this is the new substances are produced here. But in this chemical reaction, the observation is undissolved substances are produced here. So that is called as a precipitate. So in a solution which is undissolved substance is called as a precipitate, and this chemical reactions are also known as precipitation reactions. So in some chemical reactions, precipitates also produced. The chemical reaction in which a precipitate is formed is known as a precipitation reaction. So now we will learn about the evolution of gases. In some chemical reactions, some gases also can be released. Let us see now how the gases releases in some chemical reactions. For this activity, we have to take one conical shape flask, cone shape flask or conical flask. So this is the conical flask. Take some zinc granules in the conical flask, zinc granules. Next, pour 5 ml of hydrochloric acid. Pour 5 ml of hydrochloric acid. HCl is the formula for hydrochloric acid. So here a chemical reaction takes place between the zinc and hydrochloric acid. A gas is produced here. If you introduce a matchstick, burning matchstick here, this burning matchstick will put off with a pop sound. So it will put off with pop sound. So the gas which put off with pop sound is known as a hydrogen gas. So chemical reaction like this, zinc react with hydrochloric acid, it produces zinc chloride and hydrogen gas. So this is the chemical reaction for this. In order to balance the equation, 2HCl we will take. Zn plus 2HCl gives rise to ZnCl2 plus H2. So here hydrogen is a gas. Gases can be expressed with upward arrow mark. previous activity, precipitates can be indicated with a downward arrow mark and gases indicated with upward arrow mark. So these are the three important activities in this lesson we can understand. So here a chemical reaction, sometimes heat energy will be liberated. That reactions are called as exothermic reactions. The chemical reactions, precipitates are formed, precipitation reaction. The chemical reactions, sometimes gases also can be liberated. So endothermic reaction also is there. The chemical reactions in which heat energy absorbs. For example, N2 plus O2 gives rise to 2NO minus Q. Q is the symbol for heat energy. Here heat energy will absorbed. Such type of chemical reactions are called as endothermic reactions. So here CaCO3, calcium carbonate, when you heat this, then CaO plus CO2. So here heat energy is absorbed. The chemical reactions in which heat energy absorbed are known as endothermic reactions. So here 4 concepts we have covered. The chemical reactions in which heat energy liberated are exothermic reaction. Example, calcium oxide react with water, it produces calcium hydroxide along with heat energy. And some chemical reactions in which heat energy absorbed are known as endothermic reactions. Example, N2 plus O2 gives rise to 2NO and minus Q. So Q is the symbol for heat energy. And precipitation reactions also we have seen. When sodium sulfate react with barium chloride, it produces barium sulfate and sodium chloride. In that chemical reaction, barium sulfate is a precipitate. The precipitates we will indicate with the downward arrow mark. Now here in the fourth one, when metal zinc react with hydrochloric acid, it produces zinc chloride and hydrogen gas. Hydrogen gas will be indicated with upward arrow mark. So these are the important concepts in this lesson. And continuation part, how to balance the chemical equations. Let us see, I will explain 2 chemical equations, how to balance the chemical equations. Before going to that, we have to know law of conservation of mass. According to law of conservation of mass, mass neither be created nor destroyed during the chemical reactions. So here the total number of elements present in the reactant side must be equal to total number of elements present in the product side. So according to the law of conservation of mass, every chemical equation must be balanced. So here for example, balance the chemical equations. One of the chemical equation we will see now. 2KClO3, potassium chlorate gives rise to potassium chloride plus oxygen. Here this is unbalanced equation. If you observe that in LHS means left hand side reactants will be, RHS right hand side products will be, and we have to write elements. What are the elements here? So potassium, chlorine and oxygen. Potassium 1 and 1, reactant side 1 and product side 1. Chlorine reactant side 1 and product side 1. But oxygen reactant side 3 are there, but product side 2 are there. So here if you observe that there is a inequality, means not same in the reactant side and product side. But according to the law of conservation of mass, total number of elements in the reactant side must be equal to total number of elements in the product side. So first we will to balance the equation of oxygen atoms in the reactants and product side, we have to take 2 number as coefficient for the reactant side as 2KClO3. By that oxygen 6 atoms are there, and reactant side KCl plus 3O2, 3 number we have to take as a coefficient for the oxygen atoms. So by that here 2 3 is 6 oxygen atoms, 3 2 is 6 oxygen atoms, both are balanced. But here potassium chloride, to balance the potassium and chlorine also, here 2 potassium and 2 chlorine are there, we have to take the 2 number as coefficient for the potassium chloride. 2KClO3 gives rise to 2KCl plus 3O2. So now if you observe all the elements in the reactant side and product sides are same. So now this is the balanced equation. So whenever you are balancing the equation, keep it in mind, the number should be taken as a coefficient of the molecule. You should not change the chemical formula of the compounds. So appropriate number should be taken to balance the both sides, reactants and product side. Let us see one more chemical equation, how to balance the chemical equation. C3H8 plus O2 gives rise to CO2 plus H2O. Let us see balancing the total number of elements are there. What are the elements? Carbon, hydrogen, oxygen. Let us see carbon, 3 atoms are there, LHS, and RHS, 1 atom is there. Hydrogen, 8 are there. Oxygen, hydrogen 8 are there. Hydrogen 2 atoms are there. Oxygen 2 atoms are there. Here 3 atoms are there. So here every element different numbers are there. So in order to balance this carbon, hydrogen, oxygen atoms, we have to take the appropriate number. First, in order to balance the carbon atoms, reactant side 3 are there, product side only 1 is there. First we have to take that C3H8 plus O2 gives rise to 3CO2 plus H2O. So carbon atoms are balanced by taking the 3 number for coefficient of carbon dioxide. Now hydrogens we will balance. C3H8 plus O2 gives rise to 3CO2 plus 4H2O. Because 8 hydrogens in the reactant side, if you taken 4 number coefficient for the H2O, 4 to is 8 hydrogens. Now let us see oxygen atoms. In reactant side 3 to is 6 plus 4, 10 oxygen atoms in the reactant side. We have to take the 5 number as coefficient for the oxygen. 5O2 gives rise to 3CO2 plus 4H2O. So if you observe clearly, all the elements are balanced here. C3H8, 3 carbon atoms in reactant side and product side 3 carbons. 8 atoms of hydrogen in reactant side and 4 to the 8 atoms in the product side. 5 to the 10 oxygens in the reactant side, 3 to the 6 plus 4, 10 atoms of oxygens. So here this is the way of balancing chemical equations. So in this lesson, especially in exams, if they want to ask the questions, why should we balance the chemical equations and what information will be given by the balanced equation, how to balance the chemical equations, what is exothermic and endothermic reactions. So these are the very important concepts in this lesson. Children, if you follow these are the main concepts in this lesson, you will never lose the marks from this topic. So, and last but not least, still now if you not subscribe my channel, please subscribe my channel and share this video to all your friends. Thank you.